Okay, now I'm going to do the next distribution. Okay, when I distribute to the second fraction, only the x plus 1 factor reduces. So you have left 2x, x minus 1. Okay, you see that plus there? You can't cross anything out. You still have a plus. Okay? Bottom left, only the x minus 1 factor cancels out. And so you're left with 3 times x plus 1. And a minus. And then here, only the x plus 1 factor cancels out. And we are left with 1x, x minus 1. Okay, do not get carried away. You cannot cross anything out yet. All I did is I turned my complex fraction into a simple fraction. I did not get rid of PEMDAS. You still have implied grouping symbols around the top and the bottom of your fraction, which means you cannot divide until you finish the parentheses in the top. Okay, so I need to distribute and add. Now, I notice that this is why I left extra space here, because I don't want to rewrite the problem a bunch. I notice that's just the difference of squares. So I'm going to do a little bit of multiplying before I rewrite again. And this is x minus 2. Okay, now I'm going to FOIL. When you multiply 3 things, just pick 2 things at a time and multiply. X cubed minus 2x squared minus x plus 2 plus, okay, 2x. You just 2 at a time when you multiply. So here we get 2x squared, right? This is a plus minus 2x. It is not above me to, right, draw my like terms out. It's totally fine. Okay, so I've got my like terms. Now, I still haven't done my denominator yet. Okay, so I'm going to do my denominator. Yeah, question? No? Just, okay. All right, I'm going to pick 2 at a time. So 3x, x plus 1, and then this one is just x squared minus x. Right, leave a little bit of space. Okay, there's a couple steps of simplifying or multiplying here. Okay, so we get 3x squared plus 3x, subtract x squared, and then add x. All right, so I'm looking for my like terms. Okay, so my last step. Okay, so those actually just cancel. So we get x cubed minus 3x plus 2, which is not a quadratic. Okay, it's cubic. In the denominator, we end up with 2x squared plus 4x. Okay, remember the house question? Now you can reduce. Now it's a single fraction. Now you can try reducing. Now if you did it a slightly different way and you did it as the top, the bottom, and then the divide, you don't have quite what we have. It just means that one of us isn't finished yet, and it's us right now. Okay, this isn't quite finished. I think I can factor and reduce this. Now it's a little bit tricky because that's cubic. You're like, oh, how am I supposed to factor that? Well, GCF, patterns, quadratic, grouping, synthetic division. That's the catch-all for factoring. Okay, so I'm looking at this, and I notice that if I plug in 1, I get 0. That means it's a factor. If you can evaluate to 0, it's a factor. That's the remainder theorem. Yes, you have to remember stuff. Now, am I going to put that on a quiz or a test without like having you practice it? No. Okay? But it just happened to pop up in this question. I'd give you a hint, be like, you must factor this. And then tell you it has to factor it and let you try to figure it out. Okay, so I'm going to do my division here. 1, 0, negative 3, 2. This is where those skills that we learned, You cannot forget them. Yes.
How'd you know that one would factor?
I guessed. I looked at it. No, I looked at it. You have to. It's the factors of the last term and factors of the first term, and so it's a 2. My answer choices are 1 and 2, plus or minus 1 and 2, maybe 1/2 if you forget what order they go in. That's it. There's only 4 choices, and so when I'm guessing, I always start with 1. And I noticed that, look, my coefficients 1 and 2 were opposite of that middle one. 1, you're just looking at the coefficients to see if they add to 0. Okay, but I guessed. Okay, so let's factor this. X minus 1, x squared plus x minus 2. Now it's quadratic. Does that factor any further? Yeah, it does. Now it should start, if you did the problem in a slightly different order, it should start looking like what we have here. And now I'm going to factor this denominator, which is a GCF of 2x. Cancels out. And you're left with x minus 1 over 2x. Okay, a lot of steps. Am I going to make you do synthetic division? No. Okay? I'm not. But it happened in this question because all of my other factoring methods didn't work. If you had done the problem in the multiple steps, top, bottom, then divide, this is the answer you would have ended up with. Okay? So x can't be. What can't x be? So I'm going to go back. I'm going to look at my whole problem. Okay? I'm going to circle all my denominators. X plus 1, x minus 1. So I've got 0, -1, +1. And I'm going to check to see if I have any new factors pop up in the denominator. So right after, right here, see that? -2. There's that new denominator factor. You have to look for it. If you have a divide, you have to look for the other denominator, which happens when you reciprocal or when you turn it into a simple fraction. All right? This is the tricky one. If you missed that value on your quiz, it was minus a whole point. Right? If you missed the other denominator for the divide question, it was -1 point. Okay. So let's look at the other two, which are a little bit simpler. I'm going to copy it to the other page. Okay. Question 2. 2 over x plus 3 over y over 4x over z. Okay, and that's a y. Okay, least common denominator. X, y, z. That's it. It's just x, y, z. Here are my denominators. X, y, z. They're all different. They're each a factor. And so I'm going to multiply. This one I don't need to rewrite. Okay, times x, y, z times x, y, z. Notice that what I'm multiplying by is equal to 1. That's why this is staying equivalent. I'm going to distribute. I'm going to write this step out because it's a little bit shorter. I think some of you might benefit from seeing the actual distribution, which I would not typically do because it's a lot of extra writing. But if you see it once, that might help. That's what the distribution looks like. You actually distribute it to every term here. Now I can see the crossing out that maybe you didn't see the first time. Two yz plus 3xz all over 4x squared y. The hard part is knowing when to stop. Can I reduce that? Well, do you have any common factors? I see a common z. But I don't have a common z on the denominator, so there is no reducing. Now, I'm looking for my restrictions. 0, 0, 0. And then I look at my new denominator. I don't actually have any new factors, so there's no new restrictions. Keep in mind that a number, right, it can't be 0. There's no restriction there. Okay, last problem. X over 4, 3 over x. X over 4, 3 over x. Okay, this is order of operations. You can add inside the parentheses. Okay, I'm going to do it 2 ways. Let's consider this. Okay, common denominator. So I'm going to multiply by x here and 4 here. Okay, so multiply by x, multiply by 4. Okay, that's the inside. Negative 1 power means flip the fraction. But notice that there's no operations to be done inside of the parentheses. That's kind of mixing your rules from Unit 5 to this unit where I put an exponent there. I don't need the 1 power, so it's just 4x over this. You have to be careful with the operations. Because this inside is not simplified, if I were going to do it the other way, I would do it like this. And then it's a complex fraction. It's because of the addition there. That's why you can't just call this 4 over x plus x over 3. Right? You can't just flip each fraction. It matters what the operations are. If there's an add or subtract, you've got to do that first. Before. Okay, see how I didn't lose the grouping symbols here? I didn't actually flip these 2 things. Okay, so now I could do my least common denominator where I multiply by 4x on the top and the bottom. Notice it's still equal to 1. Okay, so I get 4x for the top. The 4's cancel and I get x squared. The x's cancel and I get 12. X can't be 0. Okay, then I look, right, that's a divide problem because of the negative 1. I got to look for my new denominator. Ugh, okay, x squared plus 12 can't be 0. Okay, so you don't actually get anything from that. Those are imaginary numbers. I'm only listing real numbers here. So this is the only restriction that I would include. Okay, solving. Question.
Do you need to include the part with the...
No, because it's imaginary. We're only considering real numbers here. Okay, before we start the last part of our lesson, find your homework packet. You should be done or have completed work on multiply, divide, add, subtract, which means if you've done through worksheets 12 and 13, go ahead and look at 15, which is the first review sheet there that kind of mixes some of the problems. Okay, so worksheet 15. Let's take about 10 to 15 minutes. So you can either do homeworks or worksheet 15. Okay, 15 is slightly more challenging. Okay, so if you're feeling pretty good, skip to 15. If you haven't done a lot of the 12, 13, and 14, I would look for the complex fractions and I would try them. Okay, so you got about 10 to 15 minutes now to work on some things in your packet, look back over your quizzes, try some more complex fractions. Okay? So we made it through here. We're about to do this one. Because, yeah, so this is where you should be. So I'm giving you a minute to look back over after you just did some more questions to see that answers anything that you have. So you did the last one. So that's fine. So then worksheet 18 is a review worksheet also. But that's more solving. Then you got 15. So then you
Are we defining complex fractions? Don't ask that.
I don't actually ask. But that's why we include descriptors, because that's basically your vertical asymptotes. You completely reduce and then graph. Like if I'm looking at this, could I graph this? That's actually not that complex of something to graph. You got one x-intercept, you got no vertical asymptotes. It looks like this. What would my, okay, x-intercept, y-intercept, is it, what's the end behavior? What's the HA? What does it reduce to? 4 over x, which is, and so what happens, let's plot a point, plug in 1, what do you get? Actually, let's plug in 2, I like that number better.
8 over,
positive region. Remember, you have to draw it towards your asymptote. Okay, this is, we're not graphing this one. You plug in -2, you actually get a negative region. Why do we do this? Because if I wanted a graph, I'd have to completely reduce them anyways. But I'd have to restriction. But notice it's not a vertical asymptote because it's not in the final answer.
This stuff's so cool. It's just like,
So do I.
I don't, so my packet doesn't have worksheet.
Okay, does it have any of the other
It
ones?
has up until like worksheet 12. You get the second one? I don't think I did. Yeah, we got
There's a whole second part. Okay, so you're looking at your homework worksheets 12, 13, and 15. Pick one of those, look for some complex fractions.
Do not do worksheet 13. Number 5. Remember the email?
No.
I did worksheet exactly 16 and 17. Wait, where'd my pencil go? I just had it.
Yes. So, if I...
Oh yeah.
This one counts, this one counts, this counts. So when you're looking at a fraction, 0 over 5 is 0. So that's why I have to consider the numerator of that denominator fraction also. Because that makes me divide by 0 overall, not just undefined. Yeah? Okay.
Oh yeah.
Okay, how are we doing? I would, right, maybe try one of these and make sure you get to a complex fraction, which is on the back. Okay.
You should be on number 15, not 14.
Yeah, 14 is level 1.
Yeah. I
Whereas
should add that
15
level
is
for like
level
step it up.
3. So cover up the other factors and just look at 2x squared over 3.
Do you not know who Simone is?
Yeah, so,
Simone.
so what I would do is,
Simone.
What do you go by? Like El Libertador? Oh, wait, you're French, not Spanish.
The Liberator?
Yeah.
What's your
What's his name? I just Simone Bolivar. He's the George Washington of like Latin America.
Nacho Libre? Machu Picchu? Nacho Tequito? Quesadilla?
I'm gonna be real with you. I didn't learn how to factor properly until this school year. True. Because I missed words today. What? I missed words, so yeah. I was also homeschooled in middle school, so. I remember like your first biology. I remember like in biology, you would think it was the closest online class. Like I remember the homework station show. Honestly, I forgot. You for like 3 months, and you finally turned it in. Yeah, it was like your first quarter grade was like a number 5, just a grade. You know, project you never got to get in.
Wait, no.
Your freshman year was just like an entire rumble, just the whole year.
I don't remember like biology.
I don't remember some biology. Actually, I remember some like meiosis.
I remember like cell.
Oh yeah, I remember that evolution stuff. The mitochondria is the powerhouse and stuff. Some of this stuff is like so easy. Sometimes it would be like hard. It was like, do you remember the carbonate? This is also what got me on the car and all my fucking coefficients. I was doing this super. I got some ridiculous answer like you have to plant 4 billion trees a year. I keep up with that. I was like, there's no way.
Okay, but you can't just use those numbers.
Oh my god, you sound so like. Check. You know where blood is?
Oh yeah, that's your blood. I think I am.
I guess I didn't
Oh my god.
Oh yeah. I mean, people call me emo, man.
Well, then,
Let's do
you're.
But I'm not.
Yes, you are.
Oh, you're good.
I guess I didn't.
Yeah,
You are.
you only need to multiply this by X.
That was correct.
No. 2x squared minus 2x minus 6x.
That was
I don't have it.
Yeah, you are.
So there will be an extra review sheet that has more graphing on it. But honestly, you've got enough access to the package you have now. There's graphing. Oh, your first package, right? The graphing one. There's extra review sheets in it. So if you do those, plus the review sheets that are in this package, now the test is actually.
Have you seen on the Ant-Man and Thanos?
Ukraine and Russia and China.
Oh, no.
Sadly, those are from Ireland.
That's how you beat that.
You got 10 minutes?
My ultimate.
We're gonna do something else for the last 35 minutes of class. About 5 to 8 more minutes, and then we're gonna do our last topic that's included on the test, which is Thursday, right? Give you extra days to study.
Wait, then it's just 2x minus 1.
Okay, so look. The first has to multiply to 3. The last has to multiply to 3.
Oh. Because the 2x makes it a
Okay, so this is actually kind of an important skill then, so we're going to do this again. 2x squared minus 7x plus 3.
It's the same thing as the one above it, right?
Okay, so you see this, multiply to 6. Okay, pick your 2 numbers. What are your numbers?
-6, -1.
Okay, keep those numbers in mind. Go like this. Okay. you gotta pick 2x, right? And x. Now, when we do our FOIL, these are actually my outer and inner numbers. Okay, right? Don't we usually do our grouping like this? But it's slow. Okay, so 2x times what can give me -6 or -1? -3. Okay, now what times 1x will give me this? Okay, check it. 2x squared. Yes. -6x minus 1x. Plus 3. So your multiply add numbers, that kind of just tells you like, yes, I can factor this. Then you have to be like, let me write my factors, but don't just slap some numbers down there like this, because that tells me you're not even looking at what you're doing. You're just like, oh, I think I'm supposed to do this with my numbers. No, that has nothing to do with this expression. Okay? Yeah.
So this one, you just want to
So you see how the numerator is a single fraction and the denominator is a single fraction? How do you divide by one fraction? Multiply by the reciprocal.
But
Okay, good. I got you. Hold on. You could. So why can't I just flip this one? Because I'm not dividing by a single fraction. Can I just flip this one? Yeah, because I'm dividing by a single fraction.
so you would do
So
this
yeah,
over one.
yeah. So I could do this. This is where that PEMDAS
Oh, yeah, that works.
set is not really Okay, notice I didn't lose my grouping symbols where necessary.
I know. That's why I did it.
I didn't lose my grouping symbols. How do you divide by a fraction? You multiply by the. How do you divide by one fraction? You multiply by reciprocal.
You would just turn this.
And then I would then I'd actually have to guess. Then I'd actually have to do my PEMDAS in order to do this problem. Look, can I reciprocal this? No, because I don't multiply by reciprocal two fractions. You want one fraction, so you'd actually have to add that first. Right now, that's a complex fraction, so you've got two choices. Order of operations, which is fine. Or least common denominator. Two choices, doesn't really matter which. Sometimes one seems easier than the other, and you just do it. Especially when you've got those especially when you've got these types of problems, with very small denominators, it's much easier to do it this way. Sometimes with the binomials, it's easier to do it that way. But that's a single fraction, means you just multiply by the reciprocal. Okay. About 2 more minutes on some practice, and then we're going to do just one more thing for our notes.
Yeah, you clearly don't.
Oh, you have multiply by x also.
You get this.
That's why. Okay, so yes, because there is only the least common denominator, as long as it's not complex fraction, will be the yes. Yes, yeah, no. It's only with division that you have got extra restrictions. But this one, not 6 and 5. Just those. Not this one. It looks like you included this one. Oh, you got it. Oh, you got it here. Okay, you got it here. Okay, just making sure that that's what we're looking at. Just those 3 things. Okay. Yeah. Okay. I'm working on them. Maybe while you guys are taking your tests, I'll be able to finish them. No, the one I just handed back, not yet. Maybe later today. So 2x squared minus 4x. All right, good. Yes. Yes. Okay. Lesson 6, solving with rational expressions. Okay. Okay, we do have domain restrictions. Those are the same things we've been talking about. Values that make the denominator 0. I labeled it number 1 because you need to list those things when you start the problem. Because there's domain restrictions, there could be extraneous solutions. Whenever you have a graph that is not continuous, okay, right, square root graphs had an endpoint and one arrow, means they did not cover the whole domain. Well, this is a not continuous graph, means we're missing pieces of the domain, which means we could get extraneous solutions. Okay, we are going to how to solve. First step. Reduce or /and clear complex and simple fractions. And we're going to do this by using the least common denominator. Now I have two statements up there. The first one says reduce. Okay, I'm going to reduce any fractions that I see I'm able to reduce. Common factors, okay? Maybe I turn a complex fraction into a simple fraction. But the second thing here is we're going to clear the simple fractions, which means once I have an equation that's just a fraction straight across, we're going to get rid of the fraction and then solve. Second step. Solve the resulting equation. This first one's almost too easy. Yeah, okay, so let's do this one. Example 1. 3/2 minus 1 over x equals x over 2. Right? Not a lot there. But what makes this different from the equations that we've seen in the past is that now I have a variable in the denominator. That's what's different about the equations this unit, is you have a variable in the denominator. First thing we are going to do, list out my domain restrictions. X can't be. Only where the variable is. Just zero. Yeah, just zero. Okay, great. Least common denominator. Right, I already circled the denominator, so what is the least common denominator? 2x. Okay. All right. Properties. I have an equals. Okay? I have an equals, which means in order to stay equivalent, whatever I do to the left side, I have to do to the right side. So I'm going to multiply. Look at my grouping symbols. You have to multiply the left by 2x and the right by 2x. Notice that's equivalent because I'm doing the same thing on the left as the right. This strategy is different from multiplying by 1. Okay, let's distribute and see what happens. The 2 reduces and you're left with 3x. The x reduces and you're left with minus 2. The 2 reduces and you're left with x squared. Okay, so if I look back at my steps, there was no reducing in these fractions, okay? So I cleared the simple fraction by multiplying by the least common denominator. That cleared the fraction. Solve the resulting equation. Okay, what kind of equation do you have? Search the Q. Quadratic. How do you solve a quadratic?
Factor it.
Before you factor?
You bring everything to one side.
Yeah, let's do 0. I like positive x squared, so I moved everything to the right. And solve. Right? Now it's a just regular quadratic equation. Solve it. Yes. Okay, so let's write our factors in. Okay, and I'm going to write down my restriction right next to it just so that you remember to include it. Those are the solutions. This is the restriction, which in this case would be a vertical asymptote. Am I going to ask you to graph them? Not necessarily. Okay? Yes. Oh, when you multiply by the least common denominator, it will clear the fraction. Doesn't it just reduce to 1? Look, reduces to 1. Reduces to 2 over 1. We don't need to write divide by 1. Okay, so let's try a different one. Example 2. I like this one, I guess. Okay, 4 over x minus 2 minus 3 over x plus 1 equals 8 over x squared minus x minus 2. Whoop. There you go. Okay. Restrictions, least common denominator. Okay, there's my step. My least common denominator. Just two factors. And clear the fraction. Multiply by LCD to clear the fraction, which in turn removes the x from the denominator and makes it simpler to solve. Subtract. Okay, solve for x, see what happens. Okay, so we get 4x plus 4, 3x plus 6, plus 6. I guarantee you this almost exact question shows up on your test, and like 50% of you mess up that number right there. Distribute your negative. Depends on what kind of mood I'm in, whether I take off like 1, 2, or 3 points. Don't mess up your negative, okay? So we get 1x plus 10 equals 8. So x equals -2, which seems reasonable. Notice how I'm not plugging my answers back in. I'm just assuming that they're going to work. Okay. Last one, and then we'll change it up a little bit. Okay, yep.
Is there a way we could check? Or?
Yeah, you can plug it in. It's kind of tedious. 4 over -4 minus 3 over -1 equals 8 over -4 times -1. Right?
Yeah.
It's kind of slow. Now, that's the easiest one to check ever because that's just -2. Okay, so let's try this one. X minus 1. This one has something different about it. See if you can figure it out. Okay, there is something different about this question. Restrictions, least common denominator.
see what happened? No, because you're doing it, that's why it's different. Because we're multiplying by this, but we're doing it on both sides of the equation. It's like, how do you keep equations equivalent? You do the same thing on both sides. How do you keep an expression equivalent? You multiply by 1. That's the difference, right? This least common denominator does a lot of good stuff, but you gotta do it in the right way. Yeah, put parentheses there. Yes. That's why the implied grouping symbols are important. Yep. Okay, how we doing? Figured out what's different. Yes.
Can I miss it?
Not yet.
You gotta get almost to the answer before you find it. You gotta get to the answer before you figure out what's different. Because it pretty much looks exactly the same. Don't say it yet. Right? It looks almost the exact same until you get all the way to the answer step.
No one turned your number. You yelled at so loud. I don't even You yelled it. My friends heard it outside.
So you can almost predict where you have to look for them, and then just make sure that doesn't happen.
Unless you want to fighting our title turns signs, I suggest that you stop yelling at. They might try to if you were making like there's no way anyone wants to I have another couple of
Yes, keep going. That's good. Alright, go from there.
I have zero.
It makes so much sense.
I don't use Reddit. There is no answer.
Yes.
Take so much March Madness. How do you know what an entitled parent is?
That's what's different.
Wait, Mr. Reason.
Okay, I'm gonna show the first step.
The answer can't be up. It's one of the right?
There's no answer.
What?
Yeah.
Because it's a domain.
Okay. So.
Oh, I get it.
Okay. So I've got my factors. Great. I can list my restrictions. X can't be -2 and -1. They're not even that hard to list because just adding and subtracting. There's no extra division here. Shh. I'm going to multiply by the least common denominator on both sides of the equation. Okay? Guys, your least common denominator does a lot of good things, but you got to do it correctly. Equation, equivalent, do the same thing on both sides. Now, your grouping symbols. When you multiply one side of an equation, it's grouping symbols. Okay, so I'm going to distribute, and both of those factors are going to cancel. Plus, only the x plus 2 cancels. Only the x plus 1 cancels. Okay, so now I'm just going to see what I can do. First, outer, inner, last. Alright, and now I got to combine all my like terms. I'm going to draw a line down my equals. So I get x squared. So I get 3x. So I get plus 2x plus 1 equals 0. right? I could do a little combining. And factor. X plus 1, x plus 1, x equals -1, but I'm going to put that right next to my restrictions. If you solved and got -1, but